Hey everyone, welcome back to our Complete NumPy series in 2025. In the last video, we installed NumPy and we saw that why it is such a powerful library for numerical computing. But what we saw was the theoretical concepts. Today we will actually create some programs on NumPy, and what are we going to learn is we are going to see the introduction to the core component of a NumPy array, and that is called the ND array. Okay, so the core component of a NumPy array is ND array. We will see how to create the ND array. Then we will check the properties of that ND array. We will create a multi-dimensional ND array. See, what ND array means is n-dimensional array. So it can be of any dimension, one dimension, two dimension, or any dimension. Okay. Next thing we will see is indexing and slicing in NumPy. And then we are going to learn about how to modify our NumPy arrays. Okay. So the first thing which we need to do is we need to create the NumPy array, and for that we will first import NumPy. So once we import NumPy, we generally do it as np. It means we will use it with the name np. And the first thing which we are going to do is we are going to create a NumPy array. So if you are ready, let us get started. So let us go to the introduction part and create a NumPy array. So let us say we have a data which is of type list. Okay. So 1, 2, 3. Now, if you want to convert this data to a ND array, okay, what you have to do is you have to say ARR is equal to np.array. Now, np.array is the method which actually creates a NumPy array or ND array. We just need to pass the data inside it. So let us pass the data. Now, if we print the ARR, it will be very similar to the data, but the type of ARR will be different. So let us see what is the type of ARR. Okay. So type ARR. All right. So we will print the data and print the type of data. Let us save this code. Let us run this code and let us see what is the output. So in the output, you are getting the data or the ARR, and the type you are getting is numpy.ndarray. So it means this ARR is of ndarray type. Okay. All right. Now let us check the properties of this array. So what are the different properties which we can check is the first thing which we can check is the shape of the array, or shape of the array means how many rows and how many columns are there in each dimension. Okay, or we can say in simple words how many elements are there in this particular array in each dimension. So our array is a one-dimensional data. So we just need to know for the first dimension that how many elements are there in the first dimension. So we know it is a like three elements are there in our first dimension. But how we can check is we can just say print. So we need to print the shape. Shape will be equal to, let us say, comma arr dot shape. All right. So once we say arr dot shape, it will find the shape or the number of elements in each dimension of the array. So let us run this code again, and shape is 3, and you will see the output is in the form of a tuple. Now why it is a form of a tuple? Because see, we have to output the number of elements in each dimension. Right now we just have one dimension, but we can have two dimension, we can have three dimension, right? We will create multi-dimensional array, then we will see we can have many dimension, right? So we should have a array, or we should have a tuple to show the shape, because we have to show the shape for each dimension. So the first element 3 inside our tuple is showing the dimension or the number of elements in the first dimension. Okay, so 3 means in the first dimension we have 3 elements, which is true, right? Next, let us try to see the size of our array. So for that, let us say print size, then size is equal to comma arr dot size. Now arr dot size will find the size of the elements. Now what are you thinking that what can be the size of element? Well, this will be 3. Okay, so the size of element is the number of elements in the whole array. It doesn't depend on the dimension, it just means that how many elements are there in the whole array. So right now it is just a one-dimensional array with 3 elements, so the output will be 3. So let us see, let us run the program again. So this time you will see the size is 3, and this is an integer because this is representing just a single value, that how many elements are there in our whole array. Let's clear the output. And next what we can print is what is the data type of our array. So we will say print and dtype or data type is equal to arr.dtype. Okay, so arr.dtype is used to find what is the data type of each element of our array. Okay, so save this, and let us do one more thing. Let us print the dimension as well. So we will say print dimension is equal to comma arr dot ndim. Now see, we are seeing two things, dtype and ndim. Dtype will tell you what is the data type of each elements of the array. Ndim will tell you what is the dimension of our array. Okay, so we know that the dimension of our array is, it is just a one dimensional array. So let us see what will be the output. So run the program again. So you will see, okay, I have not saved it. Let me save it again and run it. So now you will see the dimension is 1. It means it is a one dimensional array, and data type is int64. It means every element in our array is of int64 or 64-bit integer. All right, next is we are going to learn about creating a multi-dimensional arrays. Now before moving forward, just let me tell you that you don't need to worry if you're not able to understand few things. You can always comment it down in the comment box and I will answer for it. And if this seems a bit overwhelming to you, a bit too much for you, don't worry, this is just an introduction. Once you build the practice for it, once you see more videos on it, you will be able to understand every concept and every actual required concept for you to get started and be an expert in NumPy. All right, so let's move forward. Let's create a data. Let us take another data, like, okay, we can name the same variable name, and this time create a two-dimensional array. Now you see, this is a two-dimensional array. How we can say that is, see, we have a array or we have a list. Inside the list we have another list as a data and another list as a data. So it is a list of list. Okay, so it is a two-dimensional data, and in reality this will be this will look like something like this: 1 2 3 4 5 6. So this is the first row, this is the second row, and every row has three elements and we have total two rows. Okay, so this is how you can visualize it. It is easy to visualize the two-dimensional data. It is very hard to visualize the three-dimensional data. And it is almost impossible to visualize, four-dimensional or five-dimensional data. But this is something you can just visualize inside your mind. So for the ease of understanding, I'm taking two-dimensional data for now. Next thing what we can do is we can check all those properties again. So first thing what we have to do is, let us just make sure that this data is of list converted to np array or nd array actually. So we will say np dot array, and this time we'll pass the data inside it again, and let us run the same code again to see what is the difference now. Okay, we will see the shape, size, data type and ndim. Okay, so before I actually run the program, let me comment it down for previous run. And before I actually run it, pause the video and just think what should be the actual output. Okay, all right, let me now run it. See, this is the actual output. The data type will like, see the data. Okay, I think this is the previous output. Okay, this is the previous output. The first two output you can just ignore. Let us see this one. The shape is 2 by 3. What it means is the first dimension is having two elements. It means the first dimension, which is the outermost array, it is having one and two elements. The second dimension will have three elements. So the second dimension is actually the list of lists, right? These two data are representing the second dimension. So all the dimension, like, see, the important thing to understand is every dimension should have same number of element. You cannot have it like 1 2 3 and then 4 5 6 7. Okay, let me actually quickly run it and see, we are getting an error, right? Because you cannot have different dimension or different elements in same dimension, different number of elements in the same dimension. So let me clear it. remove this again, and let us go back to our understanding of our concepts. So shape is 2 by 3. Why? Because we have two rows, like these are representing the rows, and every row has three elements. So 3. What is the size? Next is size. Size will be 6. Why? Because we have total 6 elements, and this is something you can find from the shape itself. 2 into 3 is 6. The data type will be same because we are using the same data type, an integer. So it is int64, and the dimension this time is 2. Okay, so we have now a two-dimensional data. We can have a three-dimensional data as well. We can have four-dimensional data as well. If I show you a three-dimensional data, what you can do is I can just copy this comma and paste it here again, and I can actually pack it inside another list. Okay, just pack it inside another list. All right, so now you see I have this outermost list representing the first dimension. This list is having 1 and 2 data, and inside every list I have another list, like we have 1 and 2 data. All right, and inside this list we don't have a list because but we have an elements, so these are like 3 elements. So if I run the code again, this time the shape will be 2 by 3. Okay, I have not saved it, so that's why I was amazed with the output. Now you see the shape is 2 2 3. It means the first dimension has 2 elements, the second dimension has 2 elements, and the third dimension has 3 elements. The total number of elements are now 12. The dimension is now 3. So I think now you are getting the idea of what are these properties and how do they actually work. And the important thing is you get the idea of ND array. All right. Next thing what we can actually do is we can learn about indexing and slicing. So let us do that. Let us create a simple array now. Okay, instead of this, let us create a simple array because this is just a beginning. Okay, so arr is equal to np.array, and this time let us pass few simple data 1 2 3 4 5. All right, now indexing means that we just need to find some element using indexes, and slicing means that we just need to find some range of elements, uh, if we are able to provide the starting and stop point, like the starting index and the stop index. So let us see first how we can do indexing. So we just need to say print arr of 0. Well, this is very simple to understand. What is the first element of arr? That is 1, and this will get printed. First let us comment it up. Let us comment this as well, and this time run this code and you will see 1. Okay, if I change it to 10, you will see 10. So it is simple indexing. Okay, whatever index you provide, it will give you the output. And the indexing works almost similar to Python's list, so you can use the same concept to understand it. If we say 1, we will get the index 1, which is 2, and if we say -1, we will get the last element. All right, so 5. All right, so now I think you have the basic understanding of how indexing works in NumPy array. This is very similar to Python's list. Let us see how slicing works. Again, slicing is also very similar to Python's list. Well, it gets complex when you have more dimension, but that is something we will see in the future videos. So let us see the concept of slicing. So let us try to print arr, and let us print it up to third element. Okay, so what should be the output? Okay, so it should be 10 2 and 3. All right, because up to 3 means up to 3 index, not including 3. So 0 1 2, which is 10 2 and 3. So let us run it. So 10 2 and 3. All right, if you give it a starting index like 1, so it will start from index 1, it will go to index 2 and not go to 3. So let's see, index 1 2, right, index 2 3, right. So this is the basic concept of indexing and slicing. This will get a bit complex when we are using multi-dimensional array, but for a single dimension or two dimension it's very easy to visualize, but the concept will remain same. It will just get complex, so do not worry at all. We will see all these things in the future videos. Now let us see how we can modify the array. Well, modifying the array is also important, and this is again very similar to how we do it in Python's list. So if we say ARR of 0 is now 100 and print ARR, so this time what it will do is we have it like 10 2 3 4 5, but the output will be 100 2 3 4 5. So it's 100 2 3 4 5. Ignore this. This is the output for this one. Okay. Next is, let us see one more concept in modification only. We can actually modify a range of elements. Okay. So if we say ARR 1 to 2, okay, and then this should be, see, we are saying 1 to 2, let us see 1 to 3. Okay, so 1 to 3 means like 1 colon 3 means 1 2 3. All right, so 1 index 1 index 2 not including index 3, so we have to assign two elements. So let us say 10 comma 20, and now we print it. So what it will do, it will first change the element of, or modify the element of index 1 or index 0 actually, which is 10. It will modify it to 100, then it will take the index from 1 up to index 3 but not including 3. So it will be index 1 and index 2, and it will update the value of 2 to 10 and 3 to 20. So let us see the output. Let me actually clear this first and let us see the output. So see, now we have 100 10 and 20. I think this actually satisfies few things and makes you understand how the n-dimensional array in NumPy works. We saw few properties of it, properties like shape, property like size, data type, n dimension, which is ndim. We did saw these concepts. Now I think this should be the end of this video. Just make sure that you practice these concepts, and in the next video we are going to explore dtype, that is the data type in, we'll explore it in a deeper way. We'll understand more concepts about data type, because just fetching the value of data type is one thing, actually understanding how data type works in NumPy is a different thing. So that is something we are going to see in the next video. So if this video actually helps you in understanding NumPy, you can help me or support me by clicking that like button. And if you're new to the channel, just make sure you subscribe it as well. And I will see you in the next video of understanding NumPy's data type. All right.